Hello, I'm Lee. In this video, I'm going to show you the array implementation of a sorted list. So this is a list class we have seen from previous module, and we purposely keep the public interface unchanged. The only difference is this time we are going to use array, a dynamic array as a data structure. So for a dynamic array, take a look. So here's the data type. We don't have any array allocated yet, so we are going to allocate it in the constructor. And also we have two integer to keep track of two separate things. One is the current capacity of the array, and that's a physical capacity of the array, how big is the array. Another one is the logic size of the list. For example, I could have an array of 100 elements, but only 3 elements are there. So it's 97 other spots are not occupied. So this size will be 7, capacity will be 100. And also I have a constant integer which is static. Static means it's a class variable. The whole class only got one copy of this. We really don't need to keep track of this one in individual object of this class. So that's the difference between static and non-static variable. Non-static member variable means it's instance variable. Individual object keep their own copy. So if I have list 1 will have its own array, its own capacity, its own size. And the list 2 will get its own array, own capacity, and its own size. But this list 1, the list 2, they don't keep track of this default capacity. It's a list class that keep tracks of it. So that's the difference between a class variable or static variable and instance variable. Those are called instance variable because they sit in individual instance. And also I have a private function called expand array. So it's a dynamic array, so it's possible to fix the growth of the array. We will look into that function later. So that's the data members. Now let's take a look at the implementation. So in the constructor, you see we have to allocate the array. And we have to take a guess to allocate how big the array should be. And after that one, let's see how do we make sure we have enough capacity for newly added data. So let's take a look at the insert function. For the insert function, when we come here, the first thing we do is we test the logical size against the physical capacity. If they equal, that means we don't have space for the coming data. So we have to expand the array. So now let's take a look at how do we expand the array. So this is how we expand the arrays. First, we update the capacity. So in this case, I just add 10 to them. And actually, usually people like to multiply by some factor, like multiply by 2 or some preferred factor. But I just keep it simple, just add 10 there. And we allocate a new array with this bigger capacity, so using a temporary pointer here. Then we loop through the original array and do the copy. So you see this performance will totally depends on how big the array is. If it's a huge array, that will take a long time. And also take a look at this assignment operator. It's an object assignment. So that's an overloaded operator in our data class. So if this data got 10 different fields, you're going to copy that 10 different fields. So don't be fooled by this one simple operator. The operation could be much more than this one assignment operation. So this is potential performance penalty here. You're doing the copy, then remember to deallocate the original array, otherwise you got memory leak there. And assign your array to this temporary pointer. You see, this is the reason we use dynamic array. For dynamic array, we it's possible to reassign this pointer. But for static array, the pointer for static array is a constant pointer. You cannot make it to point to anywhere else. So this is how we expand the array. The operation include allocate bigger enough, then do the copy, then delete the original array, then point your array to this new array. Point to your array name to this new array. All right. Now let's see, we take care of the expand array part, and in order to insert something, we have to first find the position to insert. Well, we're not hitting the end of the array and you're not at the position yet, we just keep on looping. And you see here we use the overloaded less than operator. I believe we compare name in that less than operator. You can double check. And if the data already exists, we return false. Otherwise, now take a look here. We have to shift array. We have to shift the array down to make space for this new element. So this shifting is another performance penalty here. You have to shift. So it's unlike to keep an unsorted array. Unsorted list, you can just append it. Here we want to insert, then it involves shifting. Again, overloaded assignment operator here. And after we make the shifting, we can put this data at that spot and remember to increment the logical size of the array. Alright, so that's how you expand the array and how you insert something into the array. And remember, in the constructor, you need to allocate memory, otherwise this code will crash because you don't have that memory allocated here. You have to allocate it before you use that array. Thank you.